All right, students, that's a little bit more of guitar boogie. All right, so we're going to boogie down to some uh, special triangles, kind of some applications of stuff here. So we get all set up here, and then we'll get started on this. Okay, so I think what I was going to do is like about 3 different examples of some things here. So this is like a beach, okay? There's a Barbie doll here on the beach. There's a nice palm tree there. There's a nice sunny day right there. So what we're going to do is use this information to find H. So this is all about similar triangles. So I'm going to kind of just do what we were doing earlier. I'm going to relate the big triangle to the small triangle. And you have similar triangles in this diagram because you have the small triangle that will have 12 and 2 meters. Barbie is 2 meters tall. And then we have the big triangle that looks like it has 84 meters H. And the reason this is a similar triangle is because of angle-angle similarity. There are, 2 angles that are in common, so that's enough to make them similar triangles. So what I'm going to do is just match up the corresponding sides. So I'd have H and 2 like this. Okay, and I got that, and then I'm going to match up the other corresponding sides, which would be the 84, the big, and the 12, like that. Okay, so what we say is H is to 2 as 84 is to 12. And then we can solve this equation by cross multiplying. So we have 12 times H is equal to 2 times 84. That'll be 12 times H. And if you do that, that would be 168. Now we can divide both sides by 12 to find what that height is. Okay? All right, you can do that with a calculator. Let's see, 168 divided by 12 is equal to 14. And we do want to put units on that. So 14 meters would be the height of that palm tree. So we could measure how tall Barbie is. Her shadow, this would be like her shadow. And then if we could measure also the shadow of the palm tree, then we could figure out how tall the palm tree is. Okay, so similar triangles are things that come in handy. Okay, next example I want to look at, this is height of a flagpole. So we have this situation. We have a guy here who's 1.4 meters tall, and this distance here is 3 meters. We have this distance is 8, and then we have the flag like that. So first of all, we got to see, do we have similar triangles? Well, you have a mirror right here, and there's what's called the law of reflection. This also kind of works the same way if you're playing pool. If you hit the pool ball up against the bank, it will bounce off at exactly the same angle. So we call this like the angle of incidence and the angle of reflection, and they are the same. So this angle and that angle are the same based on the law of reflection. We also have a right angle. We're going to assume that the flagpole's at a right angle. We'll also assume that the man is at a right angle. Okay, so what we get is we have 2 triangles. We have, and it goes like this. I'm going to flip these around a little bit. We got the small triangle, which has a side of 3 meters and 1.4 meters, has this angle and has the right angle. If I flip the other triangle, just flip it, I end up getting X, I get the right angle, and I get this. And then we would have this side right here would be 8 meters. Okay, so we got the big triangle and we got the small like that. Sometimes it's useful to just redraw the triangles kind of corresponding to each other. So we got the angles corresponding and so forth. So what I'm going to do on this is I'm going to make a kind of big to small. I'll relate it this way. So I've got like this. The X is going to correspond with the 1.4. And then that will be equal to, and again, we're going to match the side on the big to the side on the small. So that would be 8 over 3 like that. Okay, now we can cross multiply. So we'll have 3 times X equals 8 times 1.4. And take my calculator and do 8 times 1.4, which is 11.2. So I have 3 times x is equal to 11.2. Now I can divide both sides by 3. So I get x is equal to 11.2 divided by 3. That will give, and this one I'm going to have to round off a little bit. If I do 11.2 divided by 3, I'm going to get approximately 3.7 meters. Okay, when I use the approximate symbol, I usually use this tilde. Okay, so that would be approximately what that value would be. Okay, and you can kind of see, does this make sense? Well, 3 and 8, 8 is a little bit more than twice as much as 3. So this answer should be a little more than twice what 1.4 is. So that seems pretty rational to me. Okay, all right, last example. Okay, this would be kind of an accessibility thing. So this says, how high is the ramp when it's 2 feet from the building? Okay, so we're looking at, it looks like this distance right here is what that h is. So we need to look for a couple of triangles on this. What we have this small triangle, and this small triangle, it's a right triangle, and what it has is the information it's given. It's got a right angle, it's got this acute angle right there, and then since this distance is 2 and that's 20, then this distance right here would be 20, the whole minus the part, that would be 20 minus 2, or 18 feet, is what that would be. Okay, and then this small triangle is going to have h, what we're trying to find. Okay, if you look at the big triangle, yet again is a right triangle, and it looks like its entire side is 20 feet, and this corresponding side is 20 feet like that. So the way this corresponds is they're kind of showing you that they would share this angle, and they also share this angle and the right angle. It only takes 2 to do that. So there's this angle and this angle and the right angle. So angle-angle similarity would tell us that those are similar triangles. Once we conclude that they're similar, then we can make a proportion. So this time I'm going to look at the small triangle in relation to the big. Okay, I'm going to match the h with its corresponding side. That would be h over 2.5. And then I'm going to match the 18 with the 20. Okay, I'm doing the small to big. So I've got the 18 to 20 like that. So h relates to 2.5 as 18 relates to 20. Then I can cross multiply. Okay, so I'll have 20 times h is equal to 2.5 times 18. So that will give me 20h equals, and I can take my calculator, 2.5 times 18 is going to give 45. Then I can solve this equation. So I just need to divide both sides by 20. And on this, I could reduce the fraction. If I have 45 divided by 20, I could divide top and bottom by 5 to get 9/4 of a foot. Okay, so you could write that as 9/4 of a foot. 9 divided by 4 is 2 and 1/4. So you could write this as 2 and 1/4 of a foot, or you could write it as a decimal as 2.25 feet. So all of those things could be written in the same way. Okay? So the idea on this is this. This is always worth showing students one more time. We got h is 2.25. So if I pulled out my calculator, you know, it's pretty easy to tell that this is the right answer by doing this. And it doesn't matter what order you do this in. I'm going to match up the corresponding sides. I'm going to do 2.5 divided by 2.25. That will give some number. And I can do the other corresponding sides in the same way. I can do the 20 divided by 18, and I should get exactly the same thing. And I do. Okay, so that's how that works. That's how you can quickly check and verify answers. Okay, that'll wrap us up. That's 3 applications of similar triangles. Hope you enjoyed the video and hope you rock and roll on your homework. All right, good luck.